A tetrahedron has edges that are 10 centimeters in length. Find the height of this tetrahedron to the nearest tenth of a centimeter. First, we observe this figure. AB, AD, AC, BC, BD, DC, they are equal to each other. That is to say, the right triangle ABC, ACD, AED, DBC, all of them are regular triangles. So we isolate the bottom DBC, this triangle here. That is to say, the triangle DBC should be a regular triangle. Now, if we connect BH and extend DH to point N, connect BH, extend BH to this point, we connect CH, extend to this line segment to here, we can figure out the following information. We have known AH is the height of this tetrahedron, so AH perpendicular to the triangle DBC. In fact, this this AH perpendicular to the plane in which triangle DBC lies in. And we can figure out AH perpendicular to HC, AH perpendicular to BH, AH perpendicular to DH. So we can figure out three right triangles. That is to say, this right triangle, and this right triangle. We have known the three hypotenuses are equal to each other. AH is the common side, so BH, HC, DH equal to each other. DH, BH, HC equal to each other. So we write out DH equals BH equals CH. And from this information, we can figure out this right triangle, DH equal to HC, so this angle equal to this angle. Similarly, this angle equal to this angle, this angle equal to this angle, and this angle should be half of this angle, because this is a regular triangle, so we have known this is 60 degrees, so this angle should be equal to 30 degrees. And DH should be perpendicular to this line segment. Why? We can prove this. Because this one, they are equal to each other. And DN is the common side. This angle equal to this angle. So these two angles are equal to each other because DBN, this triangle DBN congruent to triangle DCN. So DN perpendicular to BC. So now we focus on the right triangle HNC. In this right triangle, we can figure out cosine angle HCN equal to cosine 30 degrees equals the adjacent side NC over hypotenuse HC. NC equal to half of the line segment BC, so it should be 10 over 2. It should be like this, 5 over HC. We figure out HC equals 5 over cosine 30 degrees. Cosine 30 degrees equals square root of 3 over 2. So it should be this number. That is to say, HC equals this value. Now let's focus on the right triangle AHC. In right triangle AHC, we can make use of the Pythagorean theorem to figure out AH squared equals AC squared minus HC squared. AC we have known it is 10 centimeters, so 10 squared minus HC. Here we have this value, so we can figure out 100, 103, 203. Then we can figure out AH equal to 200 over 3 square root notation. It should be 10 2 over 3. The approximation should be 8.2 centimeters. This is the final value for AH. That is the height of this tetrahedron.